All right, so we have on the left a 4-cylinder tach and on the right a V8 tach. And I'm using a cheap Amazon frequency generator to output a signal. Right now I'm generating at 66 hertz, which is the signal for 1000 RPM. And you can see that the V8 tach is reading correctly, but the 4-cylinder tach is actually reading double the RPM. Now I have another video, I'll put a link in the description that shows how I calibrate these tachs and how I go about hooking up the frequency generator. It's pretty easy to do. These tachs generally have 3 inputs on the back. One is your 12-volt power, one is battery ground, and the other is a signal. That signal is your frequency that is being output by this. I only paid 10 bucks for this on Amazon, this frequency generator. But if you want more info on that, please check out that video. This video is going to go over how we can change the resistors on this tach to make it equal to make it read equally to what the V8 tach reads. Now, if you were to 5/0 swap a 4-cylinder car and use your stock cluster that's in there, you'll find that the RPM is actually going to read twice what you're actually doing. So I'm going to go into some detail as to how to change some resistors to do that. Now, as you'll see here, I'm going to adjust my frequency, and as I sweep up to 133 hertz, which is the signal for 2000 RPM, as you see, I have 2000 RPM on the V8 tach, but the 4-cylinder tach is at 4000. I'm going to continue to sweep up higher. So as we go to 3000 RPM, you'll see that we're actually going off the scale here. These tachs aren't that accurate in higher range. You can use the pots to dial that in, but we're going to go into detail here as to how to modify these tachometers so that your 6-cylinder tach will also read 3000 RPM here. So obviously your first step is you need to get the tachometer out of the car. Now this video is going to focus primarily on the 87 to 89 style tachometer. That'll be evident by the flat bottom here, and you'll also notice the part number here. This is E8 1988. I believe there's an E7 version as well. I do have an E9 tachometer in my car, and the easy way to tell the generation is by the adjustment pots here. So the early 87 and 88 cars will have a single adjustment pot, and the 89 and later cars will have a second one mounted right next to it. The purpose of the adjustment pots is to offset any the tolerance of the resistor for the tachometer being slightly out of spec. There's usually a range on that resistor. It might be 3%. So at 3% can cause a big difference. So if you have, you're getting an input for 3000 RPM and your resistor is a little bit on the higher end, your RPM will actually be, I believe it'll be a little bit lower here. And if your resistance is on the lower end, it'll actually be a little bit higher. So what this adjustment pot allows you to do is to offset that. But I'll get into more detail. I'll kind of do a quick overview for most of you who just want to see how this is done, and then I'll get into some more explanation as to how this actually works for those of you who want to learn something. So step 1, pull a needle, and they usually just pull off just like that. And then when you flip these over, there are 3 nuts, that need to be taken off. One here, one there, and one there. So simply go ahead and remove those, and you can take this unit off. All right, so once you have those 3 screws removed, you can simply separate the gauge face from the tachometer. Now you want to be careful handling this. There's a small pin there, obviously. You do not want to damage that. But here is basically your board, and this should be the same for 87 to 89, exception 89 having the second adjustment pot here. But the resistor that we want to focus on here, for those of you who just want to get to the point, is this one right here, this blue unit here. So you're going to locate off this capacitor here. There's a diode right there, and then one resistor here, and this blue one is the one that you want to focus on. You're going to change it to a 24k ohm resistor. 24.5 k ohms might actually be a little bit better, but I had a 24k ohm resistor and it works. So that's what I'm going to quote as saying is what you need to do. And it's pretty easy. You're just going to basically desolder it from this side, remove the resistor, and solder a new one in. I already have done that here in this case. I've already gone through this tach. But again, this blue resistor here, let me see if I can zoom in real quick. This blue resistor right there is the one that you want to change out. So I've already gone ahead, like I said, and changed this resistor out, and the resistor that was in its place before was this one here. A little tough to see the bands, but if you were to program that into a resistor calculator that tells you what the colors coordinate to, it comes to 64.9 k ohms. That was the original value. Now the first thing I did was compare that value to what was on the V8 tach here, and unfortunately it didn't work by swapping the exact same resistor here. The resistor in the V8 tach was 60.4 k ohms, but I tried swapping that and it did not work correctly. So that tells me that there's a little bit more going on in terms of differences here. But swapping this resistor was able to correct the reading and get the RPM in the correct range. The V8 tach had a 60.4 k ohm resistor, and like I said, I swapped that one in and it didn't really work. So really, like I said, 24.5 would probably be ideal, but this is a 24.5 k ohms would be ideal. This one is 24 k ohms. Now what I did here, and I'll show it in a moment, is I adjusted the adjustment pot. This is a 20 k ohm adjustment pot. I set it to 10 k ohms to get it into the middle of the range, and then I used a potentiometer to dial in what resistance I would actually need on this particular location to get the tachometer correct. Alright, so I have it set up here. I've got the potentiometer. You can kind of barely see. I have it set up on the middle leg and one of the outside legs. But this is a 20K pot, 20K potentiometer. And as you can see here, as I adjust it, it'll run, this one runs up to 16.5, but typically they run 0 to 20K. And what I did here, as I scroll down to the bottom here, you can see as it drops down to almost 0 ohms. What I did here was split the difference, just to give me a range of adjustability. Now, I went to 10K by just turning it like this. But to be honest, now that I have run through the full range and see that max is 16.5, I probably would have gone down to maybe 8K or so, and that would have given me middle of the range. In that case there, I probably would raise my resistor that I'm installing up to maybe 25, 26K ohms and try that. But if you set this to 10K ohms, like I did, it still offers you plenty of adjustment range there, and I can show that later on. But that's what I did. Was what you want to avoid doing is putting the resistor in with this maxed out, because if you do that, you're going to have no adjustment. You'll have adjustment one direction down, but you won't have the other adjustment the other way. So basically, by setting this somewhere in the middle here, again, I would probably go 8 ohms here, but when I did this, I actually set it to 10 ohms. 10 ohms still gives you plenty of adjustment, so don't worry too much about it, but you just want to be away from one of the ends. Now, one thing I was a little bit surprised to see when I took this apart was that the resistor that was installed was more than 10% off from the stated value from the bands on there. So in other words, if it said 64.9 k ohms on the bands, I believe I measured 55 k ohms, which is significantly off. And that may be why these tachometers, as they get older, tend to be way out of range and notoriously inaccurate. Those resistors just drift over time or never were in spec, and what you need to do is actually come in here and use your adjustment pot to kind of adjust back to the value that they need to be at. That's why I was saying if you were to turn this adjustment pot down 2 k ohms, you would need to compensate by raising or lowering this resistor up. But like I said previously in the video, adjusting this to 10 k ohms, I was able to use a 24 k ohm resistor here and get this to function perfectly fine. So in my previous video that I did on tachometer adjustment, I did show how to hook the frequency generator up, but I'll go over that really quick just to show folks how they can hook up these things just to test this on their own bench. It's really not that difficult at all. All right, so here's the frequency generator. I got this on Amazon for about 10 bucks. I am using a larger 30 amp power supply, but you really don't need much. You can probably use a 1 amp power supply from a wall jack that plugs in, a cheap one. But these frequency generators hook up pretty easily there. It's just voltage negative, voltage positive, so red and black off the power supply. And then you have your PWM signal output here. This is what I'm using to drive the tachometer. Now I also have another lead you need to feed the tachometer here, so positive, negative, and then that's really all you need off the frequency generator here. On the back side of the tachometer, we have 3 pins. B would be battery, G would be ground, and S is your signal. So by using these various alligator clips here, you can just come in here, clip your positive to battery, click your negative to ground, and then come in here and put your signal on the S wire. And that's all there is to it. Again, frequency generator, positive, negative into the frequency generator, and this is your signal output, which is green. And then you just need to provide 12 volts to the tachometer here. That's all you need to do. What you're going to do is adjust your hertz, and as you can see here, I can just spin this knob. 133 hertz is 2K RPM. So really you can just set it to 133, hook up your tach. You'll need obviously the gauge face and the needle. And you can tune your adjustment pot to compensate if your resistor is, your value is slightly off. All right, so I have this back together now. I put the 3 nuts on. It's a little tricky to do and get that to tighten up. But one thing I want to show is how to reset the needle. Now, when the power is off on these tachs, they tend to go back to pointing directly at 0. So really all you need to do is carefully put the needle on and just kind of adjust it based on where 0 is. Give it a nice little push, and then you can try and move it here to see. If it's not right, simply pull it off and reset it again. But that's why it's kind of critical here that you may want to use the frequency generator to output a signal and then adjust your pot here, because number one, if the resistor values aren't what the bands say, they're off slightly, you want to compensate that by using the potentiometer. Number two, if you don't put the needle on perfectly square, you'll want to compensate for that as well. So I'm going to do one last hookup with the frequency generator here, and I'll show you how to do a final adjustment, and then you should be good to go. All right, so we're hooked back up. And I'll just show real quick, like I've explained before, power to the B, ground is your G, and then S is your signal out to your frequency generator. Let's just make sure they're not touching. But I have this set for, center this, I have it set for 333 Hertz, which is the signal for 5,000 RPM. And as you can see, it's not sitting at 5,000 RPM. So if you were to blindly just change the resistor and put this in your car, you'll be in the ballpark, but you're not exactly where you need to be. Now, if you remember, I set the adjustment pot to around 10,000 K ohms, but the maximum was around 16 K ohms. So I'm not quite in the center range here. I'm a little bit offset. So that could be why we are slightly under 5. But the adjustment pot, like I've shown a couple times here, is located here. You just need a small screwdriver. And with it in there, I'm just simply going to turn it slightly and adjust it for 5,000 RPM. Now, one thing to note is since I did not center the adjustment pot fully before I put that new resistor in, the values aren't exactly aligned to be centered. So you'll see here that I can drop this all the way down to almost 3,000 RPM, but I can only go up another 1,000 RPM. This is still perfectly acceptable. I don't see anyone that's going to need to tune out 1,000 RPM unless your resistor values are way out. In that case, you may have to revisit the main resistor that you put in, and you may have to up it maybe 10,000, 5,000 K, 5K ohms or 10K ohms. But as you can see here with the resistor, with the potentiometer full range being 20,000 ohms, this is what 20,000 ohms gives you in terms of adjustability. So really, you can put a 24K ohm resistor in there. You can put a 23K ohm resistor in there. You don't have to be spot on because, as you can see, you have plenty of adjustability to dial it in. But again, I have this set to 333 Hertz, which is 5,000 RPM. So I'm going to come in here and just set it close to 5,000. And then we'll cycle it down and check out the other range here. So I'm dropping it now. This is 4,000 RPM. Going to continue down. This is 3,000 RPM, 200 Hertz. And then we'll go down to 133 hertz, which is 2000 RPM. So this is 2000, and we're a little under it here, but like I said, I'd rather be more accurate at 5000 than 2000. This is close enough for daily driving. But I'll stop there. Now, again, I've said this a couple times. This is covering your 87 to 89 tachs. Just a disclaimer on the 89 tach, that has 2 adjustment pots. I'm confident the setup is the same with the 1 resistor, but you may have to take what I've explained here and kind of experiment a bit with that to see if that holds true with that. Now, the 90 to 93 tachs are a little bit different. The board is different. Somebody else before me has shown what resistor to change. So I'm going to put a photograph showing the location and what resistor. They said that they changed the resistor out to a 20k ohm resistor in the location I'll show in a second. And that got that set up the unit for them. I still recommend getting your frequency generator and dial it in here, because as you can see, you have some wiggle room. You're just using that main resistor to get you in the range, and then you're kind of tuning to get that all set. Hopefully you have learned a little bit from this video. If I do get my hands on a later 90 to 93 tach, I'll show how that conversion is done. Right now we'll just go off the prior knowledge that I'll share in the photograph earlier. But if I can get my hands on it, I will make a live video that'll kind of show more detail where that particular resistor is and such. But hopefully this was helpful to some, and maybe if you're not looking to put a 6K tach in, hopefully it gives you some information regarding how these tachometers work, how the resistors that are internal to them drift over time. You may want to put a new resistor in, or use the frequency generator to adjust your, your range, get it more accurate. So thanks for watching.